Welcome you all for the concrete technology session. In this session, we are going to study about the fifth module, that is special concrete. So, in that special concrete, we are going to study the different types of concrete. One is the self-compacting concrete and ready-mix concrete, lightweight concrete, and fiber reinforced concrete. Okay, so like this we are going to study the different types of a concrete which are used in construction. In that, the first one we are going to study is the self compacting concrete. So what is self compacting concrete? You know, the compaction means what the we are going to compact the concrete, usually with the help of tamping rod or with the vibrating machines. Okay, so like this we are going to compact to remove the voids which are present in a concrete. So normally in conventional concrete or in normal concrete, we'll do the compaction to avoid the air voids, but here there is no such vibration is required. The concrete itself will get compact. That type of concrete is called as a self compacting concrete. So making concrete structure without vibration have been done in the past. For example, placement of concrete under water is done by use of tremie without vibration. Mass concrete and shaft concrete can be successfully placed without a vibration, but the above examples of a concrete are generally of a lower strength and difficult to obtain a consistent quality. Modern application of self-compacting concrete is focused on high performance, better and reliable and uniform quality. In olden days, they have done without vibrating or without compacting the some of the underwater works, but they are not achieving the proper strength. But the modern technology has used the self-compacting concrete, which will achieve the same strength as the normal concrete. So if it is the self-compacting concrete, what are the materials or what are the ingredients present in that self-compacting concrete, that we have to study. So what are the benefits of this self-compacting concrete? That is also mentioned. Self-compacting concrete has been described as the most revolutionary development in concrete construction for several decades. Originally developed in Japan to offset a growing shortage of skilled labor, it has proven to be a beneficial from the following points: faster in construction because the compaction time will be remaining, reduction in site manpower, no man is required for the compacting the concrete, better surface finish, easier placing, improved durability, greater freedom to design, thinner concrete sections, reduced noise level. The compacting noise will not occur, so the reduced noise level and the self-working environment. Yes, right. No manpower is required. It is self-working. So the self-working environment. So if you are achieving that compaction, what are the materials which are present? That we'll see. So that is material for SSC. This is very important. In previous questions, question paper, they have asked define self-compacting concrete and mention and explain the materials used for self-compacting concrete, that is SCC. So the first material used for this SCC is ordinary Portland cement. 43 grade or 53 grade can be used. Okay, the cement is used as usual. And aggregate, the maximum size of aggregate is generally limited up to the 20 size. 10 to 12 mm is desirable for structure having a condensed reinforcement. Wherever the possible size of aggregate higher than 20 mm could also be used. Well graded cubical or rounded aggregates are desirable. As we know, the aggregate size of 20 mm or sometimes 10 to 12 mm with a rounded and well graded are desirable. Fine aggregate can be natural or manufactured, that is M sand. The grading must be uniform throughout the work. The moisture content or absorption characteristics must be closely monitored as quality of SCC will be sensitive to such changes. Particles smaller than 0.125 mm, that is 125 microns, are considered fines which contribute to the powder concrete. So you should specifically mention these sizes. So the fine aggregate of a size 125 micron size is preferred, and fine coarse aggregate of 20 mm or sometimes 10 to 12 mm graded, well graded and rounded shape aggregates are used. And next is water. The quality of water must be established on the same line as that of using reinforced concrete or pre-stressed concrete. So the good quality of a concrete which is not having much of the carbonates and bicarbonates will be preferred. Chemical admixtures. Super plasticizer is an essential component of SEC to provide necessary workability. Remember, in chemical admixture we are going to add the super plasticizer to achieve good workability. New generation super plasticizer termed polycarboxylated ether, that is PSE, is particularly used for SSC. Remember that the name of a super plasticizer used for concrete is polycarboxylated ethers, that is PCE, is used in SEC. Other types may incorporate necessaries such as viscosity modifying agents for stability, air entraining agents to improve the freeze thaw resistance, and retarders for control of setting. So based upon the type of work, the different type of chemical admixtures are added. Remember, super plasticizer, air entraining agents, retarders and VMAs, that is viscosity modifying agents, are also added. And other than this chemical admixture, some of the mineral admixtures are added like fly ash, GGBS, silica fume, a stone powder or some fibers. So we'll already studied these mineral admixtures in the second module. So the first one is fly ash is an appropriate quantity may be added to improve the quality and durability of a SSC. The fly ash is the waste which is obtained from coal. Okay, that is. And ground granulated blast furnace slag, that DGBFS, that is which is metallurgical process of iron. The in furnace, whatever the waste which is left out, that is called as a GGBS. That is also used as a pozzolanic material. Silica fume is also added to improve the mechanical properties of SSC. Silica, during the extraction of silica, whatever the fumes will come, that is also added. Stone powder, finely crushed limestone, dolomite and granite which is from a quarry sites will also added for the concrete. And fibers may be used to enhance the properties of SSC in the same way as for the normal concrete. So remember, what are the ingredients of this SSC? One is cement, aggregates, in aggregates, coarse aggregate and fine aggregate, water, mineral admixture and chemical admixture. We should remember water, chemical admixture. Chemical admixture are super plasticizers, air entraining agents, retarders and VMAs. Okay, and the mineral admixtures are fly ash, ground granulated blast furnace slag, silica fume, stone powder and fibers. Okay, so these are all called as the ingredients of a SCC. Okay, so requirements for self-compacting concrete. Why the self-compacting concrete has required? Okay, because it is have a filling ability, passing ability and segregation resistance. So to avoid the segregation in the normal concrete, we went for the self-compacting concrete. So the mixed design procedure they have mentioned. Once we study the norm mixed design for a conventional concrete, you are going to understand how to do the mixed design for this. So the mixed design for self-compacting concrete is entirely different from the conventional concrete. Remember that. So next we are going to study the important things is what are the different tests conducted on this self-compacting concrete. Okay, so that is test methods. So when there are different tests we are going to conduct, that is lump flow test, J-ring test and V-funnel test and L-box test and U-box test. So in that today's class we will study the first test, that is slump flow test. What is the slump flow test? The slump flow test is done to assess the horizontal flow of concrete in the absence of obstructions. It is the most commonly used test, gives a good measurement of filling ability. It can be used at a site. The test also indicates the resistance of segregation. So remember, advantages of slump flow test is it measures the filling ability of a concrete, and also it avoids the resistance to segregation. So you can see the picture of the slump flow test. So one cone is there, and the plate is, they have kept on plate. Okay, so we'll see what are the specification of this cone and the plate. Okay, the equipment required for this test is the slump cone having a base diameter of 200 mm. So this is the base diameter 200 mm, and top diameter of 100 mm, top diameter of 100 mm, and height of 300 mm is used. A stiff base plate square in shape having at least 700 mm side, and concentric circles are made around the center point where the slump cone is placed. A firm circle is drawn at a 500 mm diameter. So one plate is, they have placed one plate on the ground level, and on that plate they have made a concentric ring specially for 500 mm. A trowel, scoop, measuring tape, and stopwatch is used. So what is the procedure? That is, we'll see. About 6 liters of concrete is needed for the test. Okay, about 6 liters of a concrete you need to prepare for this test. Place the base plate on a level ground. Keep the slump cone centrally on the base plate. Fill the cone with a scoop. Do not tamp. Simply strike off the concrete level with a trowel. First, place this slump on this plate. Okay, on this plate, and fill that slump cone. It is a cone with the help of trowel. Okay, and remove the surplus concrete by laying on a base. Whatever the surplus concrete is present, remove it. Raise the cone vertically. Just raise the cone vertically and allow the concrete to flow freely. Then the concrete starts spreading on the plate. Measure the final diameter of the concrete in two perpendicular directions. And at when you remove the slump cone, it starts flowing. At some extent, it is going to stop. Once it stops, measure that diameter of the concrete in two perpendicular directions and calculate the average flow of the two diameter. Okay, in both the direction you measure the diameter and you calculate the average diameter using those value. This slump flow in the mm is noted. Note that there is no water and cement paste or mortar without coarse aggregate is seen at the edge of spread of the concrete. No concrete and water should remain at the surface. It should be mixed with the aggregate. So what we are going to get this test? The higher the flow value, the greater is the ability to fill formwork under its own weight. So higher should be the flow value. A value of at least 650 mm is required for self-compacting concrete. So when you do this slump flow test, at least it should spread about 650 mm. Then it will be considered as a good quality SCC. In case of severe segregation, most of aggregate will remain in the center of pool of a concrete and mortar and paste at the periphery of the concrete. When the concrete mix design is not done properly, then the concrete ingredient will not mix properly. And in this test, we are going to calculate the T50 slump flow test also. What is this T50 slump flow test? The procedure for this test is same as flow test. When the slump cone is lifted, start the stopwatch and find the time taken concrete to reach 500 mm mark. So you have marked the 500 mm from the center point of that plate. 500 mm circle you have put on the plate. So when you rise the cone, concrete start flowing. So when you rise the cone, just start the stopwatch, and when it reaches the 500 mm circle, stop the stopwatch and note down the time required to reach that 500 mm as T50 time. And this indication rate of spread of concrete. A lower time indicates greater flowability. If in less time it flows more fastly, then it shows the more flowing capacity or greater flowability. It suggests that T50 time may be 2 to 5 seconds. Okay, if you get the T50 time as 2 to 5 seconds, then it's well and good. Okay, this is what slump cone test for, slump flow test for self-compacting concrete. Next we have a J ring test and U box test and L box test that we'll see in the next video. Thank you all of you.